Section we'll discuss about multitasking, multi-threading. Okay, how it can be done in Python. So in Python, or in general any programming languages, we can use the multitasking to threading or through multiprocessing. So in multiprocessing, right, if there is a heavy computing task, then only we'll use multiprocessing. If there is a IO bound task, then we'll use threading. Okay, there is something called Python global interpreter lock. Okay, this is one lock um, that will allow only one thread to hold the control of the Python interpreter. Okay, so if there is, so only one thread will hold the interpreter, so this has to be removed, right? So we wanted multi-threading, right? So this lock has to be removed, so it can be done in multiprocessing module. Okay, so generally in multi-threading, we can use multi-threading if there is heavy computing, right? And it uses separate memory. Okay, for each processes, so definitely there is a overhead in it. Okay, but in multi-threading, it's the memory location is shared. Okay, so overhead is less, but definitely it will limit the parallelism. Okay, so we'll try to see first multiprocessing how we can do. What we will do, we will create two function, and we will implement multiprocessing and see how the both the function we can call it. Okay, so to import, so we'll do import multiprocessing, and then we'll import time. We'll define two function, maybe def calculate square, okay, and we will print maybe calculating square. Okay, um, what we will do, we can just return it. So we will put some n, so n cross n, but what we will do, it might be your function might take more time, right? So we'll try to simulate that um, with the help of time. Okay, maybe we'll hold this. I'll assume that it is taking 2 seconds. Okay, and a square, maybe we'll write for, okay, and we'll define another function, maybe cube. Okay, okay, now we will try to create processes for the square and cube calculation. Okay, so we'll okay, if name, so how we will try to call that in the main function. We'll create a list numbers 2 3 4 5 6 7 8 9 10. Okay, now we will try to create create pool of workers. Okay, so how we can do with multiprocessing dot pool. Now we need to process, right? Because there are two two function we will try to run parallelly. So these two as pull. Okay, Okay, now we will try to map the maybe the square and no cube function to the numbers. Okay, so we'll write square results square output pool dot map, and we will write calculate square, and we will do on the numbers list, right? Numbers. Okay, same thing we will do for the cube output calculate cube. Okay, okay, now we will try to print it. Okay, um cube, sorry, square output to print cube output okay. So what we have done, we have imported multiprocess, we defined two function, and no, in the main loop we try to define two processes with this pull method, and we are mapping this so that the it will run in this list, on top of this list, for it will iterate through the list. Okay, so we will try to see, your output may be different depending on computer process and all. So let's see. So what we will do, so I think this can only be done, see this is a interpreter, right? So it will not be the right thing. So what we'll do, we will put in multiproc, okay, dot py function. Okay, we'll just dot py, we will copy this. So this is interpreter, right? We cannot remove the GIL log that we discussed, right? So we will put in here, we will save it, save, and we'll try to run in a terminal. Okay, Python multiproc. Okay, as you can see, square so as you can see, it is running no, in multiprocessing way. See, as you can feel it. Okay, it is giving, see, calculating square. So it might be different for yours. So it is two processes running, right? Okay, so this is a way how we can do multiprocessing, but as you see, right, in Jupyter notebook it was not possible. So what we will do, we'll now see how we can implement threading. Okay, so we'll do directly in here, thread fun.py. Okay, so we will import threading, And then what we will do, we'll try to simulate a network request or IO by maybe define simulate IO. Okay. IO with some, we'll see, with some task, and print starting IO for task name. Okay. And we'll simulate with time dot sleep. Okay, maybe 2 seconds or maybe 3 seconds. So you have to import time. Okay. um, Now we will write print um, completed task for okay. So we imported threading and time, so we have simulated some IO with time dot sleep. Assume we have starting the IO and completed the IO, and then we will try to, what we'll do, we'll no create threads for different tasks. Okay, in a main loop. So we'll do same thing for name equal to main. Okay. Now we will define some list of tasks. So tasks equal to maybe task 1, task 2, second, task 2, 2, so task 3, task 4, task 5, task 6, task 7. Okay, we have defined 7 tasks. Okay, equal to, right. Now we will just will create a list. Now we'll try to iterate this. Okay, what we will do, so now we'll try to iterate the task. So for task in tasks, okay, and thread. So we will now import the threading. Okay, dot thread. Okay, so we will do threading, where we will do the threading on this function, right? On this function, and we will do for the task. Okay, right, for this task, correct. So whatever we iterated, we'll do threading for this function for all these tasks iteratively. Okay. So what we will do, we'll append this thread, right? So we are trying to put in a list. Okay, now how to start the thread. So to start the thread dot start. Okay, um, the thing is, it should wait also for all the thread to finish, right? So wait for all the threads to finish. Okay, so we'll do for thread in threads. Okay, so one thing I've done, threads we have appended is to be see, this is the list, right? So we should append, yeah, right. So see, thread is this thread, and we are, right, we're appending all the task in this list, and we are starting the thread. Okay, so thread dot threads. Okay, so thread dot join. Okay, so the thread dot join, what it will do, it waits for each thread to complete before continuing. Okay, and thread dot start, it will start the threading. Okay, and threading dot thread, right, thread object is an object, right? Thread object is created for each task in the list tasks, right? All these tasks, each thread runs this function, right, for all the tasks. Okay, I would say for all the thread, because each we have created thread for each. Okay, and what we will do, we will finally print, right, maybe like all IO tasks are completed. Okay, so what we have done, we have imported thread, we have defined no, simulated some IO in a main loop, right? We created different tasks, all these maybe different IO tasks. We have created a list, and then we have created different thread for each of the tasks. Okay, and put in a list, and then we started the thread, and we make sure ki we wait for the thread, for all the thread to finish, right? So we'll join this, right, and we'll wait for each thread to complete before continuing. Okay, we will see how it goes. So we will save it. So Python thread. Okay, so starting IO, so it has all started. Okay, see, completed. Okay, see, all the thread are parallelly started. So here we created two pool, right? So two pool, and here we have created all the, since there are two function, we created two uh, processes, right? For each, in this multiprocessing we created two processes for each of the function. And in threading, what we have done, depending on number of tasks, we have created thread for each. Okay, there are 7 tasks with 7 thread. Okay, and then we combine in a list and try to run all the thread, right, start all the thread together. Okay, so as you can see, again, so all the thread started, wait for 2 seconds, finish. Okay, so all the IO tasks are completed. Okay, this is the way how we can use multiprocessing and multi-threading, right, in Python. Okay, and also point to note, right, in Jupyter we tried but didn't work, because no, it will not, Jupyter notebook is an interpreter, right? It is not unlocking the interpreter lock, right? So we have to do through, we have to create a .py file and run in the terminal. Okay, that's it guys for this session.